Okay, my dear students, welcome again. You heard this new session. In the last session, we discussed about the Gauss elimination method to reduce the matrix in the form of a argumented matrix into the form of a reduced row echelon form and get the solution of the system of equations. In this class, I introduced the concept of a elementary matrix and how to find a inverse of a matrix, and then with the help of a inverse of a matrix, how can we solve the system of equation. Okay, so let's begin the what is the definition of this. Let A be an n by n matrix if there exists n by n matrix B such that AB is equal to identity and B is equal to identity, then the matrix B is called the inverse of a matrix A, a multiplicative inverse of a. Means simply we can say that if we have any matrix is given, then we can find such a matrix B which is giving you a AB is equal to identity and also BA is equal to identity. Then we can say that if A is B is the inverse of A, then we can say that A inverse is equal to B, or we can say that B inverse is equal to A, vice versa. So that means we have to inverse of a square matrix is simply we can say that if we have any n by n matrix, if there exists another n by n matrix such that if it's giving the product of these two matrices either left or right is giving the identity matrix, then we can say that B is called the inverse of A, or A is called the inverse of A, B is vice versa. For example, if we have a B is equal to this matrix and A is equal to this matrix, then we have to calculate what is AB. AB is equal to, you have a 0, 1, 1, 1, then we can say that minus 1, 1, 1, 0, then we can say that we can write into the form of this, you have a clearly you have a 1 and then you have a 0, and then you can say that minus 1 plus 1 is equal to 0, then you can say that this into 1, this is equal to 1 and this is equal to identity matrix I by 2 identity matrix. Clearly now we have to calculate the B of A, and B of A is nothing but is equal to minus 1, 1, 1, 0, then we can say that 0, 1, 1, 1, and this can be written in the form of this into this, you have a clearly 1, and then you have a multiplied by this minus 1 plus 1 is equal to 0, then you have 1 into 0, 0, then you have a 1, then again you have a identity matrix I2. So this means we have to show that ultimately AB is equal to identity is equal to, you have a BA is a 2 by 2 identity matrix. Then we can say that this B is the inverse of A. That means A inverse of A is nothing but is equal to, you have a, can say that is equal to B. Okay, is equal to B. So we can say that inverse of a matrix is nothing but is equal to B. For example, is this thing. Okay, now we have a given a matrix. For example, we don't have a matrix given. Now, how can find the inverse of such a matrix? That means by the definition, we can find any matrix which we have a matrix is there, and if we have a matrix, then we have to multiply that matrix should be given the identity matrix if its inverse exists. Okay, now suppose we have to try to find the inverse of such a matrix. So if suppose the inverse of such a matrix exists, so if inverse of such a matrix exists means we can say that there exists another matrix B, and then we can say that this is x1, x2, x3, x4, such that AB is equal to identity is equal to BA is equal to identity. If this is happening, then we can say that this B is the inverse of A. So finding the inverse of a matrix, we have to assuming that there exists a matrix, this A is invertible and matrix of inverse of A exists. So this means in order to 2 by 2 matrix, we have to take this 2 by 2 matrix is B. Now we try to find the AB matrix, means we can find the AB. So we have A and B is equal to, we have to take a product. Now if you see this means we can say that we have a x1 plus x3 is equal to 1, we have a x2 plus x4 is equal to 0, you have a x1 plus twice x3 is equal to, you have a 0, then you have a x2 plus twice x4 is equal to, you have a 1. Now you have a 2, these two equations are the same, these two equations are the same, and then we have to just say that these are the x1 plus x3, you have a x1 plus x3 is equal to 1, and then also you have a x1 plus twice x3 is equal to 0, then you have to simplify these two equations. If you have a cancel out this, so you're getting the x3 is equal to minus 1, and then we can say by these two equations you have to x3 is equal to minus 1, you're getting the x1 is equal to, you have a 2, because by the first equation. And then now the second one, you have to just say that x2 plus x4 is equal to 0. Then you have a x2 plus twice x4 is equal to 0. Then again you have a x4. This is sorry, this is x4, and this is twice x4. Then we can say that x4 is equal to this is equal to 1. So we can just get as equal to -1. Then you have a x2 is equal to you getting the 2. So this means we can say that simplify these two equations like this, x1 plus x3. Then you can just say that x1 plus twice x3. If you take these two equations, clearly if you have to subtracting these two equations, this is cancel out. You have a x3 is equal to 1, x3 is equal to, x3 is equal to -1. And then simplify these two equations, you can just start eliminating x2. Then you getting again getting, you have a minus, so minus, you have to just say that x4 is equal to, you have a 1. And then substituting x4 is equal to 1 here, so you're getting x2 is equal to -1. And then substitute x3 is equal to -1, and then x1 is equal to, you have a substitute to -1, so you have x is equal to 2. So this means we can say that we have a matrix x1 is equal to, you have a 2, x2 is equal to, you have a -1, x3 is equal to, you have a -1, x4 is equal to, you have a 1. If we have this matrix is there, then we can say that this is the inverse of this. Means we can say that now you can verify easily if you have multiplied this matrix AB, if we take A is equal to, you have a 1, 1, 1, 2, and then we have a 2 minus 1 minus 1, 1. This can be written in the form this into this. You have a 2 and -1, and then you have a -1 plus 1. This is equal to, you have a 2, and then you have a -2. Then you have a clearly is equal to -1, and you have a plus 2. This is equal to 1 and 0 and 0 and 1. This is identity matrix. Similarly, you can identify B of A is also identity. You have to just say that B of A means you have a B, we have a matrix is equal to 1 1 1. This is -1 into 1. Then we have a is equal to, you have a 1 1 1 2. This can be written in the form of a UAS, right? You have a -2 and -2 into this is okay, 2 into -1, and then you have a, this is equal to 2 minus 2, then you have a -1 plus 1, then you have a -1 plus 2, then again you have a 1 0 0 1 is equal to identity matrix. So clearly we can say that this is a clearly satisfy this condition. So this is the matrix of this. Okay, now this is the, now suppose the argument matrix and it is reduced echelon form are given. This is the we have initially argumented matrix, we have to assuming this, and this is the echelon form of a this matrix is given. Then we have a the solution of this system equation is equal to, we have a this and an inverse of a matrix is equal to B is equal to, you have to just say that 2 minus 1 -1, and this is equal to form of this form. What I have to calculating this previous form. So this means this is the, if you have this is the argumented matrix of a given matrix. This means we can say that the solution is this has an inverse matrix is B. So we can say that B is equal to this, then we can clearly verify AB is equal to BA. Here I just write this equation for this equation's argumented matrix of this equation. Then we can argumented matrix, this is the matrix, and then we have to reduce in the form of a argumented matrix. Then we getting the solution set. This solution set is giving nothing but is equal to is a B inverse, and then we can say that AB is equal to BA. Okay, so now there is a result. It says that the inverse of a matrix, if it exists, is unique. So we say that if inverse is matrix is unique. If we say that A is a matrix, B is the inverse of this A, then A is a matrix. Suppose C is again inverse, then we can show that B and C are the same if inverse is the unique. So by this property, we can say that how to calculate the inverse of this, prove this result. Assume that the square matrix A has an inverse B and C, and both inverse of matrices, so AB is equal to BA is equal to identity, and AC and BC is equal to identity. So we can say that AB is equal to, you can say that also is equal to AC by the property of this, and A is a, we can just check into this form. We show that B is equal to this. So B, we starting from this B, it can be B of identity. Identity means we can say that B of AC, and then you can say BAC, and BA is nothing but is equal to identity, then B is equal to identity is equal to C. So what we show that? We show that B is equal to C, that means the inverse of a matrix is unique. So we just simply say that we either you can start from the C can be written as a IC, and then you can say that this I is nothing but is equal to, we can say that is equal to AB or BA. We can say that this is BA, and then C, then we can say that B of AC, and B of AC is equal to, you have a identity is equal to B. So the either way, either start from the B or either start from the C. In the both the cases, we getting the solution inverse is exists, and the inverse is a unique of a such a matrix into this. So this means the problem is this: the inverse of A is exists if and only if AD minus BC is not equal to 0, and we can say that the inverse of is nothing but is the form of this. You know that this is the well-known property. You have to know that, but we have to try to show that the inverse of a matrix A is exists then only in the case when AD minus BC is not equal to 0. And if AD minus B the inverse is exists, then inverse is the form of this 1 upon AD minus BC. Then we have to DA, and then we have to minus B minus C interchanging into this form. We try to prove this result. First assume that AD minus BC is not equal to 0, and let B is equal to, this is the matrix which is the inverse of a this A. So x1 x2 x such that AB is equal to, we have a identity by the, if this is B is the inverse, then we can say that AB should be is equal to, we have a identity is equal to this matrix. Now we write a product of these two matrices is the form of this AX1 plus BX3 and so on. Now write the system of equation is this form, and now we have the system of equation of this into this form. You can see clearly. Now we try to write the argumented matrix of this clearly argumented matrix of this in the form of A B 0 0. Now you have a B Z sorry x1 x2 x1 x3. I'm sorry, I make a mistake. X1 is equal to A, x2 0, B and 0. Now we have a 0 A 0 B. Now we have a x1 is equal to C 0 D, and you have a 4 0. Now you have a 0 C 0 D, and then you have a 1 0 0 1. This is the argumented matrix of this system equation. So this way, we have to just say that argumented of this matrix. Now what we do, we have to try to make a here one, here one, here one, and then here one. So like this, we have to just say that multiply this first equation by R1 should be replaced as 1 by A R1. So this can be written in the form of this 1 0 B by A 0, and then you have a 1 by A. Now we have a this can be, I just divide also, this is in the form of a the rest of them 0 is no problem. We have to 0, and then we have a C and 0. We have a A, we have a 0, and C we have a 0 D 0, and we have a B 0 D, and then we have 0 0 1. Next step we have to make is C 0. That means R3 can be replaced as a R3 minus C times of a R1. So this means we have to, first condition is 1 0 B by A 0 1 by A as it is. Now 0 A 0 B, and now this is 0. This can be C minus this. So 0 minus 0 is equal to 0. Then you have a D minus, you have a BC upon A. So this is AD minus BC upon A. So this is AD minus BC upon A. This terms, and then we have a 0 minus 0 is equal to 0, and then you have a this is equal to 1. So 1 minus, you have a, you can say that this is equal to 0 0 1, minus b by a. So this means ab minus, you can say that 1 by a. So you can say that a minus b upon a. Sorry, this is multiplied by c. Sorry, this is nothing but this is equal to c by a. This is the c by a. Okay, this is. Okay, now we have to rest as the same 0 c 0 d 1, and now here we have the next step is r2 replaced by 1 by a r2. So this should be like this 1 0 b by a 0, and you have a 1 by a. Now second term is equal to 0. Now 1 and you have a 0, you have a b by a, then you have a 0. Next term is equal to 0, 0, you have a d minus bc upon a, sorry, and then you have a ad minus bc upon this, you have a 0, and then you have a 0, 0, you have a c, and 0, you have a d, and then you have a minus c upon, okay, this means a minus c upon a, and then this is equal to, you have a 1. Now similarly, we have to just apply here. You have to just take a main. This is divided by c. So we getting this 1, 0, b by a, 0, 1 by a, 0, 1, 0, b by a, 0. Then you have a 0, 0. This is ad minus bc, 0, and then a minus c by a. Now 0, 0, 0, 0, 1, 0, d by c, and you have a 1 by c. Now, with the help of this, we have to eliminate here 0 and here 0, and rest of them is simply equal to this. So this means R1 should be replaced as a R1, and then you have a minus ka B by a R4, sorry, R3, and this is okay, R4. Sorry, I make a mistake. This is this AD minus B. This whole thing is divided by AD minus B. So 0, 0, 1, 0. Then you have a minus c upon a. Then multiplied by divided by this is equal to a upon ad a minus bc. So this is cancel out. So this is you have a clearly ad minus bc. So c minus c upon minus c upon ad minus bc is this term. I similarly all other terms are there. So after reducing this system of equation, we getting this is the our new system in the form of this form. Now from here we can clearly say that x1 is equal to this, x2 is equal to, we have this, x3 is equal to this, x3 is equal to this. So x1 is equal to d upon b minus ac, x2 is equal to b upon minus b, and x3 is equal to minus c, and then you can just write the form of a b. So b is equal to, you have a x1, the ad minus bc is we have to take outside. So 1 upon ad minus bc we take outside. Then x1 is equal to, you have a d, x2 is equal to minus ka b, x3 is equal to minus ka c, and x4 is equal to, you have a. So we getting this whatever this we have to want. This means clearly this term, and this is nothing but is equal to, this is a b, and this is what is, this is nothing but is equal to a inverse. So what we getting this clearly, that means this is equal to a inverse is equal to this one. So inverse exactly when ad minus bc is not equal to 0, and in that case is given above formula. Okay, so now just to find the inverse of a large square matrix, because we have to just work only the 2 by 2 matrices. So that is a method is applicable. If you have a 2 by 2 matrix, we can say that inverse of this is nothing but is equal to 1 upon ad minus bc, and then we take a bd column change and multiplied by this columns, we can say. But if we have a larger matrix, if we have a b n by n matrices, and b is also another n by n matrices, and how to find the inverse of these two, means we have to get a product, because if the method is saying that find the inverse, you have just take a product of these two matrices giving identity, and b is also giving the identity. Then we can say that a inverse is nothing but is equal to b, or b is equal to b is the inverse of a. So just we have just take a be any n by n matrix, and b be another n by n matrix. So b1 b2 bn, we just assuming that the n columns. So we have it just write this is the matrix. This we have to generate b1 B2 and Bn are the n columns of a matrix B. So we have a like this. We can say that simply is equal to, we have a like this. We have a matrix B. B can be written in the form of a like this. We have a B1, B2, B3 up to Bn. This is the column of a B. And then since AB, V1, V1 are the columns of AB, and AB we can write in the form of this product of this is denoted by AB1, AB2, and so on ABN. We have to just take any matrix A n by n. We have to multiply this matrix A by n. We have to A into this corresponding the column. This is AB1. This is corresponding to the column AB2. This is corresponding to column AB3, and so on. So this is AB1, AB2, AB1, the column vectors of a matrix AB in order for B to be an inverse of A. Means we assuming that we finding the inverse of a B. That means we can say that clearly we write assuming that the inverse of a matrix A is equal to B. If B is another n by n matrix, and then another matrix, we have to multiply it by this matrix. Okay, so this means we can say that clearly these two are this form. So now AB1 is in the form of a like this. So we have to just form this. AB1 is equal to this by the, after reducing the R, R, E, F, I apply the row reduction in form of this matrix, AB matrix. So we have multiplied by AB matrix. We have to reducing this into this form, AB2 into this form, up to ABN into this form. So this means we have to getting into this form. Now in this case, we can, what is getting this, AX is nothing but is equal to 1110, AX is equal to this form, AX is equal to this form, and then they must have a unique solution. So this means we can simply say that AB1, AB2, and so on. If we have to apply the elementary row operation into this system of these equations, then we can get AB1, AB2, ABN is this form, and this AX is equal to this form AX. Then that the system has a unique solution, and now unique solution means this can be written in the form, so all n linear simultaneously reducing the n by 2 n argument. We can just write this is the matrix for A over. Then we apply the elementary row operation, and then we getting writing that there is a identity matrix is here. Then after applying the elementary row operation, where we have to converting this matrix into this form, we have to getting the 1 0 up to 0 0 1 up to 0 0 0 up to 1, and so on. And then we have to, here we have a B11, B12 up to B1n, then we have a B21 up to B2n, and so on, B of n1 up to B of nn. Then we can say that if we have to convert this matrix into this form, then we say that this is the this matrix is the inverse of this matrix clearly. For example, I just say that by the example we can explain you. We have to try to find the inverse of such a matrix. What can we do? We can write find the inverse. We can place the identity matrix right hand side in this form, and then we have to apply the convert this matrix into the form of a row reduced echelon form, and then same operation can be applied for this identity matrix. So we have to apply this whatever method apply into this matrix A, also apply the same matrix into this identity matrix. So now use the operation reduce the matrix on the left hand side identity matrix by applying the same operation to the matrix on the right. The final result, because final, I just say that I multiplied by this. For example, I multiplied this R1 repeated by minus R1. So this is R1 is the form of a 1 1 1, and then you have a sorry, minus 1 minus 1 minus 1 0 0, and you have a 2 0 0, you have a 0 1 0, then you have a minus 1 1 2 minus 2, then you have a 0 0 1. Now we have to R2 replaced by R2 minus 2 times of a R1, and R3 replaced by you have a R3 plus R1. Then the matrix is the form of a 1 minus 1 minus 1, you have a minus 1 0 0. Then this 2 minus 2 is equal to 0, then 0 minus 2 plus 2, 0 minus 2 plus 2, then you have a 0 minus 2 plus 2, then 1, and then you have a 0. Now adding these two, you have a 0 minus 1 1 0, then minus 2 minus 1 is equal to minus 3, minus 1, then you have a 0, then you have a 1. This is the matrix of it. Now next you have to this is here, so we just write in the form of 1 minus 1 minus 1, they have a minus 1 0 0, multiplied this equation by divide 1 by 2, so you have a 1 1, 1 by 2 and 0, then you have a 0 0 minus 3, and then you have a minus 1 0 and 1. Now with the help of this we have to making here this above is a 0, then above 0 means we have to just take a adding these two terms. So we have adding these two terms, we getting the second term is equal to 0 1 1, and then we have a 1 by 2 and 0, and the last term is 0 0 minus 3 minus 1 0 1, and then the first one we can just say adding these to 0, adding this to 0, minus 1 minus 1 plus 1 is equal to you have a 0, and then minus 1 plus 1 is equal to 0, then this is equal to you have a half, then you have a 0 in this form. Now again we have to divide the last one is equal to 1 by 3, so I just change here, so this is should be equal to minus 1 by 3, so this is equal to 1, this is equal to plus 1 by 3, this is equal to minus 1 by 3, and then this with the help of this r2 can be replaced as a minus times of a r2, and then rest this is should be this is equal to 1. So we just apply from this same, we can just say that, so this means we can get into form of a this form we have a matrix, so getting this identity matrix and this form, so we have original matrix is A is equal to we have a this, so we can just say that clearly this is the inverse of a matrix of a this, so this means A inverse is nothing but is equal to into a this form. So A inverse A is equal to identity, A inverse A is equal to identity, you can easily verify that because of this. You just check A is equal to minus 1 1 1, so we can just say that minus 1 1 1, and then we have a 2 0 0, we have a 2 0 0, then we have a minus 1 1 minus 2, we have a minus 1 1 minus 2, this is the A, and then we have a 2 1 4 1 1 2, then 1 1 3. If you have multiplied by this, you have a minus 2 plus 1, and then you have a minus 2 plus 1 plus 1. Like this, you have to somewhere is mistake, I think so. This is what? Okay, minus 1. 1 2 minus 1, this is okay, this is 1 2 minus 1, and then you have a okay 1 2 minus 1 2 1 1, and then you have a what is this? Okay, so correct. So this means you just try this, and then you getting this into this, then this into this, and you have to try to verify this is a identity matrix. Okay, now determine whether this matrix is invertible or not. So if it's invertible, we can write as the form of a identity matrix. Procedure describes that we have to write identity matrix and then apply the elementary row operation here. So this can be written in the form of these two operation. We just say that this 3 3. So we take R2 and R2 replaced by R2 or R3 plus minus times R1, and then we can getting into this form. Now we have to move to the next row is this thing. We have to divide this is equal to minus 1 by 5, and next we have to just taking into this form, and then you can see this is the last row is a 3 by 3 matrix coefficient. On the left cannot reduce the identity, this cannot be cannot reduce identity matrix. If it is not reduced identity matrix, then the original matrix does not have an inverse. This means we can say that this matrix cannot be reduced in the form of a identity matrix. If we cannot reduce this matrix into the identity matrix, that means we can say that whatever original matrix we have, this matrix does not have an inverse. If it is not an inverse, then this matrix is clearly is a non-invertible. And also notice this this solution is you have just said that this is 1 0 0 is there, means Ax is equal to 1 0 0 is there, but Ax of this second one, this Ax 0 1 0 is not here, and then Ax this thing you have just said that this one and this one, these two you can see these two not here. In place of this we have should be this, that this means if we have a inverse is only exists if Ax is in the form of a 1 0 0, and Ax is also in the form of a 0 1 0, and also in the form of a 0 0 1, but is not possible in this given system. So if it is not given into this system, then we can say that the inverse of the original matrix we have given this matrix is does not exist. So I think I have to stop this class at this point because we have to calculating all this how to find inverse. Next class we discuss about more about this inverse uh, of matrix, some property of a matrix inverse, and also try to solve how to get the solution of the system equation by using the inverse of a this property. So that means we just uh, discuss some basic elementary properties about the inverse of a matrix into the next class, and also uh, discuss about the how to find a solution of a system of equation by using the inverse of a matrix. Means we can just say that we can just that this ax is equal to b. That this is the any matrix system of equation can be written in the form of this. If the coefficient matrix has an inverse, then we can say that A inverse is there, X is, then A can excite AX is equal to A inverse B form. And then that we know that the just we have to prove that A inverse is equal to identity, and A inverse A is also identity by the property of a invertible matrices. So we can say that this can be written in A inverse A, and Ax is equal to, you have A inverse B. And in this case we can say that because it's identity and is A inverse B, so this means if we have any system of equation, and any system of equation can be written in the form of a argument, if the inverse of this coefficient matrix exists, then solution of this equation can be written in the form of, if this solution is exists, if the solution of a system of equation is exists, then the solution can be in the form of A inverse B form. So that means we have not using complete argumented matrix, we just check a coefficient matrix, and then find the inverse of this coefficient matrix and multiply it with the right hand side of this coefficient inverse of this matrix, we get the solution of the system of equation. So we have to discuss all this thing into the next class. Thank you very much for this.